Okay, good morning all. Are you able to see the screen?
Yes, sir.
Yes, sir.
So today we will continue with the mathematical modeling of electrical circuits. We'll try to wind up this topic today. Okay, so I just want to give you a brief preview about these two properties of Laplace transform, which is the time differentiation property and time integration property of Laplace transform. Okay. So time differentiation property, I already mentioned you in the last class. So time differentiation property of Laplace transform under zero initial condition states that if Laplace transform of x of t is x of s, then the Laplace transform of the nth derivative of x of t will be, what is it? What will be the Laplace transform of the nth derivative of x of t?
S power n x of s.
Correct. S power n x of s. Correct. Similarly, there is another property which is the time integration property under zero initial conditions. So it states that if the Laplace transform of x of t is x of s, then the Laplace transform of integral of x of t dt will be x of s by s. Okay, so please remember this time integration property. Laplace transform of integral of x of t dt will be equal to x of s by s. Is it clear? These two properties, please remember. Any doubt in this?
No, sir.
No.
Okay, so now let us start with a question. Okay, so this is a very simple question. For the circuit shown, find the differential equation representing the system. Also find the transfer function V output of S by V input of S. So the input is V in of t and AC source is given, and output is the voltage taken across the capacitor. That is what is mentioned in the figure circuit diagram. Okay. So first what I will do is I will mark the current that is flowing through the circuit. So I'm marking the current in this particular direction. You can see I have marked it using a blue arrow, that is I of t. So as soon as the current starts flowing through this particular circuit, a voltage will be developed across the resistor, the inductor, as well as the capacitor. And whatever voltage is developed across the capacitor is the output voltage in for this particular circuit diagram. So now tell me, what is the voltage across the capacitor, sorry, across the resistor R? What will be the value of the voltage across the resistor R?
VR of t.
VR of
VR
t
of
will,
t.
correct. It will be equal to what?
I of t into R.
Correct. R into I of t. Correct. So VR of t will be developed across the resistor in this particular polarity. Correct. Because current is entering the left terminal of the resistor. Okay. So VR of t is equal to, as you guys told, it is R into I of t. Now, similarly, what is the voltage developed across the inductor? What is the formula for voltage developed across an inductor if the current is I?
L into di of t divided by dt.
Correct. L into di of t by dt. So VL of t will be equal to L into di of t by dt. Okay. Now voltage across capacitor I am not checking because it is already given as the output voltage. Correct. So now I am going to write the, according to Kirchhoff's voltage law, I can write the equation for this particular circuit. Correct. So what will it be? Total voltage is V in. So V in should be equal to what? R into I of t plus L into di of t by dt plus V output of t. Correct. Yes or no?
Yes, sir.
Okay. So now I got like this: V in of t is equal to R into I of t plus L into di of t by dt plus V output of t. Okay. Now, what is the voltage across the capacitor? From the figure, what is the voltage across the capacitor actually? not in terms of current or anything. What is it actually? It is the output voltage itself, correct or not?
Yes, sir.
Yes.
So Vc of t in for this particular question is V output of t. Okay, Vc of t for this particular question is V output of t itself. Okay, so that also you should remember. Now I am going to ask you this question: what will be the current flowing in terms of V output of t? I know that the voltage across the capacitor is V output of t. Then what is the equation for current flowing through the capacitor? What is the equation for current flowing through the capacitor if the voltage across the capacitor is VC?
C into differentiation of Vc of t.
Correct. C into differentiation of Vc of t. But here, what is Vc?
V out.
V out. So I of t can be written as C into dV output of t by dt. Correct or not?
Yes, sir.
Yes.
Okay. So now I can substitute this in this particular equation. Correct. Whatever we had found. So what will happen? V in of t is equal to RC dV output by dt, correct? Plus L d by dt of C dV output by dt plus V output of t, correct or not?
Yes, sir.
Now what is d by dt of C into dV output of t by dt? What is this term? What will happen to this?
I of t.
No, no, no. What will happen to this? D by dt of dV output of t by dt. What is that? You are differentiating it how many times?
Double differentiation.
Function of V output of t, correct. So this can be written as V in of t is equal to RC dV output of t by dt plus LC d square V output of t by dt square plus V output of t. Is it clear?
Yes, sir.
So this is what is the differential equation of this particular circuit. Okay, so I am arranging it in order. So it will be LC d square V output of t by dt square plus RC dV output of t by dt plus V output of t equal to V in of t. Is it clear?
Yes, sir.
Okay. So this is the differential equation that we got. Correct. Now I am going to I want to find out the transfer function. So what we have to do to find the transfer function, it has to be transformed into the S domain. Correct. So I am going to take the Laplace transform on both sides. So I am taking the Laplace transform on both sides. So can you tell me what will happen? What is the Laplace transform of d square V output of t by dt square?
S square V out of t.
V output of
Yes.
S. Laplace transform of d output of t, dv output of t by dt.
Yes
Yes,
into V output
we.
of S.
Correct. So this equation, after taking Laplace transform, it will become LC S square V output of S plus RC S V output of S plus V output of S equal to V input of S. Is it clear?
Yes, sir.
So now I am taking V output common from the left side. So it will become LCS square plus RCS plus 1 into V output of S equal to V input of S. Correct. So from this, I will get the transfer function, that is V output of S by V input of S equal to 1 by LCS square plus RCS plus 1. Is it clear?
Yes, sir.
Okay. So this is how you can, this is a simple problem. So you can try the same circuit with output voltage as voltage across the resistor. That is the first case that you can try by yourself. And then second one, you can try with the output voltage as voltage across the inductor. So I'll give you these questions in the last slide. So you please try out, find out what will be the transfer function if the output is taken across the resistor and what will be the transfer function if the output is taken across the inductor. Okay. Now let us consider a little complex problem. Okay. So for this circuit, we are asked to find what is the transfer function V output of S by V input of S. So for this particular case, I will be using mesh analysis to do the problem. So I hope you know the mesh analysis. Now, in this particular circuit, how many meshes are there? How many meshes are there?
Two, sir.
Two meshes are there. Okay, two meshes are there. Now tell me, you know what is a mesh, right? So mesh is a closed path such that there is no branch inside it, correct? So there are two meshes. I am marking the mesh currents like this. Okay, so you have I1 of t and I2 of t. So this is the first mesh and this is the second mesh. I hope you know this, correct?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now I am going to write the mesh equations. Okay. So first we will consider mesh 1. Okay. So mesh 1 means it is this, correct? This is mesh 1. You can see this, right? When I'm moving the mouse.
Yes, sir.
Okay. So I will start from this particular point. Okay. So what is the first thing that comes? Minus V in of t, correct? Because this is the negative terminal of the voltage source, since this is marked as positive. So I'm starting from here. First one is minus V in of t plus, what is this next thing? What is the voltage across R1?
I1 of t into R1.
Correct. Plus R1 into I1 of t plus R2 into what?
I2,
I1
I1 of
of
t
t
minus I2 of t.
Correct.
minus I2
I1,
of t.
correct. R1, R2 into I1 of t minus I2 of t. So when you start from here, the first thing that comes is minus V in of t plus R1 into I1 of t plus R2 into, now R2, it is common to mesh 1 and mesh 2. But since we are writing mesh 1 now, so I1 minus I2 you can take when you are traveling in the clockwise direction. So minus V in of t plus R1 into I1 of t plus R2 into I2 of t, I1 of t minus I2 of t equal to 0. Is it clear?
Yes, sir.
Yes.
Okay. So now I will make the I1 terms to one side. So it will be R1 I1 of t plus R2 I1 of t minus R2 I2 of t equal to V in of t. Done?
Yes, sir.
Okay. Now I am going to write the mesh 2 equation. So what is the mesh 2 equation? I am going to start from here. So what is it? Starting from here, it will be R2 into,
I2 of t minus I1 of t.
correct, R2 into I2 of t minus I1 of t plus, what is the equation
L
for,
into I2 of t.
no. What is the equation for voltage across an inductor?
L into di of t by
Hmm.
dt.
But here, what is the current flowing through the inductor?
I2 of t.
So it will be L into,
di2 of t divided by dt.
correct, di2 of t divided by dt. Now, what is the voltage across capacitor?
C into dv.
What is the equation for voltage across capacitor?
So 1 by c integral I2 of t into dt.
Correct. So if I start from here, first thing that is coming is R2 into I2 of t minus I1 of t plus L into di2 of t by dt plus 1 by c integral I2 of t plus R3 into I2 of t equal to 0. Is it clear?
Yes, sir.
Okay. Now again, I will arrange these such that I1 terms will be to one side, then I2 terms and right side. Okay. So it will be minus R2 into I1 of t plus R2 I2 of t plus L into di2 of t by dt plus 1 by c integral I2 of t dt plus R3 into I2 of t equal to 0. Is it clear?
Yes, sir.
Okay. Now we got the two mesh equations. So I'm writing the two mesh equations here. Okay. Now I want to find the transfer function. So what will I do? I will take Laplace transform on both sides of this particular equation. So first equation, I'm going to take the Laplace transform. So can you tell me what will be the equation after taking Laplace transform?
So R1 into I1 of S
Hmm.
plus R2 into I1 of S
Yes.
minus R2 into I2 of S
Yes.
is equal to V in of S.
Correct. So it will become R1 into I1 of S plus R2 into I1 of S minus R2 into I2 of S equal to V in of S, because R1 is a constant. So R1 into Laplace transform of I1 of S will be I1 of S. Laplace transform of I1 of t is I1 of S. Laplace transform of I2 of t is I2 of S. Laplace transform of V in of t is V in of S. Now what I will do is I will combine the terms of I1, which is R1 plus R2 into I1 of S minus R2 into I2 of S equal to V in of S. Is it clear?
Yes, sir.
Now,
Yes,
similarly, I
sir.
will take the Laplace transform of the second equation. So can someone tell me what will happen? What is the Laplace transform of I1 of t?
I1 of S
I1 of s.
I1 of
So first will be R1, R2 into I minus R2 into I1
minus
of s.
R2 into I1 of S plus
Then,
R2 into I2 of S
hmm,
plus L into S into I2 of S
correct.
plus 1 by C
Uh,
into I2 of S divided by S
correct, correct.
plus
Plus,
R3 into I2 of S.
correct. Equal to 0, correct. So please note here minus R2 into I1 of s plus R2 into I2 of s plus L into Laplace transform of di2 of t by dt means it will become L into s I2 of s. When it is differential, it will become multiplication by s, correct. Plus 1 by c integral of I2 of t dt. Laplace transform of integral of I2 of t dt will be I2 of s by s. So this total Laplace transform of this particular equation will become like this: minus R2 into I1 of s plus R2 into I2 of s plus Ls into I2 of s plus 1 by c into I2 of s by s plus R3 into I2 of s equal to 0. Now I1 terms and I2 terms I am segregating and then combining the terms. So you will get like this: minus R2 into I1 of s plus R2 plus R3 plus SL plus 1 by CS into I2 of S equal to 0. Is there any doubt in this?
No doubt, sir.
Okay.
no, sir.
Okay. Now I will the two mesh equations in S domain we got like this. Right. Now what I'm going to do is I'm going to write it in matrix form. Okay. So I hope you know. So what will be the size of this matrix? What will be the size of the coefficient matrix? How many variables are here?
2 cross 2.
2 cross 2. So it will be like this. I hope you know how to write this in matrix form. So
Yes.
first, so R1 plus R2, I2 coefficient is minus R2, Second equation, I1 coefficient is minus R2. Second equation, I2 coefficient is R2 plus R3 plus SL plus 1 by CS into the variables, that is I1 and I2 in column form, is equal to V in of S and 0. You can see that if you expand this, if you multiply these two matrices, you will get these two equations straight away, correct? Because you can see R1 plus R2 into I1 minus R2 into I2 equal to V in of S, which is the first equation. Similarly, second row, if you do minus R2 into I1 plus R2 plus R3 plus SL plus 1 by CS into I2 equal to 0, which is the second equation. So straight away we are getting from there itself. Okay, now we have like this, correct? So now our objective is to find out V output, correct? So from the equation, I know, from the circuit diagram, I know that V output of T is nothing but, what is the equation for V output of T? Can anyone tell? What is the equation for V output of T? Output voltage is the voltage across R3, correct? So what is the equation for voltage across R3? V output of T equal to what? Look into this part of the circuit. V output of T is equal to, what is the voltage across resistor?
R3
R3.
into
R3 into I2
I2.
of T.
Correct. V output of T is R3 into I2 of T. So what is V output of S?
R3 into
R3
I2.
into I2 of S.
Correct. So to find out the output voltage, we need to know I2 of S, correct? We should know what is I2. So I am going to use Cramer's rule here to solve this particular equation. Okay, so let us use Cramer's rule. So first, for Cramer's rule, what will I do? I will find the determinant of this 2 by 2 matrix. So determinant of this 2 by 2 matrix will be like this, correct? R1 plus R2, determinant of R1 plus R2 minus R2, like this. So what is the determinant of this? You have to multiply, correct? How will you multiply? What is the determinant value?
Primary diagonal minus secondary diagonal.
So R1 plus R2 into R2 plus R3 plus SL plus 1 by CS, correct? So this coefficient, this value into this value minus this into this, correct? So it will be like this. Is it clear?
Yes, sir.
Okay. Now I need to find I2 of S, correct? So to find I2, which delta we have to find? Do you know? Delta 2. Okay. So delta 2, because I2 I have to find. There are two deltas here, delta 1 and delta 2. Okay. So delta 2 will be obtained by replacing the second column with output value, output matrix. So second column is what? Minus R2 and this value. So this column will be replaced with V in and 0. That is what is written here, delta 2. Is it clear?
Yes, sir.
So what is
Yes, sir.
delta 2? What is delta 2 value? It is a symbol value. So can you tell me quickly?
Minus R2 into V.
Plus
Minus
R2
R2
into
will
V naught. Plus,
plus
because
R2
minus
into
into minus plus.
ah, okay. So finally you will get R2 into V in of S. Correct. So according to Cramer's rule, what is I2 of S? Can you tell me? What is the formula for I2S according to Cramer's rule? Okay, according to Cramer's rule, I2 is delta 2 by delta. What is I1 of S? I2 is delta 2 by delta. Similarly, what will be I1 of S if you want to find I1?
Delta 1 by delta.
Delta 1 by delta. Delta 1 will be obtained by what? Replacing the first column with output matrix. But we don't want that, because I want only I2 of S. So I am finding only I2 of S. Okay. So I2 of S is equal to, you will get like this, R2 into V in of S divided by the delta value. Is it clear?
Yes, sir.
Okay, 1 minute. I have to put one yes, right? Okay, sorry for that. Okay, so I got I2. I2 is R2 into V in of S divided by R2 plus R3 plus SL plus 1 by CS into R1 plus R2 minus R2 square. Now, output voltage. What is the equation for output voltage? What is V output of S? We just had
R3 into
R3
I2.
into I2 of S.
correct. V output of S is equal to R3 into I2 of S. Now I can substitute for I2, correct? So it will become V output of S is equal to R3 into R2 V in of S divided by R2 plus R3 plus SL plus 1 by CS into R1 plus R2 minus R2 square. So from this, I will get an expression for V output of S by V input of S, correct? You understood?
Yes, sir.
Yes, sir.
So this is the transfer function of this particular circuit. Is it clear?
Yes, sir.
Okay. So once you know the transfer function, you can actually model the circuit using this transfer function rather than, okay, you don't have the circuit elements, but still you can know what will be the output produced by using simulation tools and all. Understood? Even though you don't have resistor, capacitor or anything. Clear? Now another method also is there to find. So I will quickly show you that. Okay. So in this method, what we'll do is first step is same. I will mark the mesh currents. There are two meshes. I am marking I1 and I2. Okay, done. Now what I will do is I will transform this circuit into S domain. Okay, so before writing the mesh equation, I will transform it into S domain and then write the mesh equations. Okay, so let us transform it. So circuit remains the same. The values is where the change happens. Now tell me what will happen to this V in of t in S domain. What will happen
V
to
in
V?
of S.
Correct, V in of S. So that is marked. Now what will happen to V output of t?
V output of S.
V
Correct,
out
V
of S.
output of S. So that also I have marked. Okay, now tell me what will happen to R1?
R1.
R1 itself. So again, I will write here R1. What will happen to R2?
R2.
R2. Is it clear? Now what will happen to L?
L into S.
L into S. So it will become SL or LS. Clear? What will happen to C?
1 by C into S.
Correct. 1 by CS. Is it clear? What will happen to I1 of T?
I1 of S.
I1 of S. And I2 of T will become I2 of
I2 of
S.
S.
Is it clear?
Yes, sir.
Yes, sir.
So this is the equivalent circuit in S domain. Okay. So now what will I do is now I will write the mesh equations. Okay. So here it will become easy because there won't be any integral, there won't be any differentials or anything because we have already transformed it into S domain, which means that all these things are impedances. SL is impedance, 1 by CS is impedance, which means that if you want to find the voltage, you just have to multiply it by the current. Understood? You understood?
Yes, sir.
So
Yes,
now
sir.
let us write the mesh 1 equation. So again, I will start from here. So what is the first thing that comes? Minus V
Minus
in of
V
E
in H.
plus, can you tell me, plus R1 into
R1 into I1 of S.
R-
plus,
R2
R2
into
into
I1 of S minus I2 of S.
I2.
correct, correct. So minus V in of S plus R1 into I1 of S plus R2 into I1 of S minus I2 of S equal to 0. Is it clear?
Yes, sir.
So now I will combine the coefficients of I1 and combine the coefficients of I2. So I'll write like this: R1 plus R2 into I1 of S minus R2 into I2 of S equal to V in of S. Done? Now tell me
Yes, sir.
what is the second mesh equation? Second mesh equation. I'll
R2
start
into
from here.
I2 of S minus I1.
Okay, R2 into I2 of S minus I1 of S, because mesh 2 we are considering. So I2 I've taken first. Okay, correct. R2 into I2 of S minus I1 of S plus what will happen? SL into I2 of S. Okay, because now it is no differentiation, nothing, because now it is in the S domain, which means that SL is the impedance. So what is the voltage across any element? Impedance into the current, correct? So voltage across inductor will be SL into I2 of S. Is it clear?
Yes, sir.
Yes.
So now what is the plus SL into I2 of S plus
1 by CS into
I,
I2 of S.
1 by CS into I2 of S, correct? It's 1 by CS. Correct. So 1 by CS into I2 of S plus
R3 into I2 of S.
correct, plus R3 into I2 of S equal to
0.
0. Correct. Any doubt in this? Is it clear, everybody?
Yes, sir.
yes.
So now I am combining the coefficients of I1 and I2. So it will become minus R2 into I1 plus R2 plus R3 plus SL plus 1 by CS into I2 equal to 0. So it is same as what we got using the earlier method, correct? Same thing. Now again, I will form the matrix. Is it clear? Again, I will find out a determinant. I will apply Cramer's rule. Okay, it is a repetition after that. That's why I'm going like this. You understood the idea?
Yes,
Yes
sir.
or no? Okay. Okay. The same, so I am just same thing only. Okay. You will get the same. So the two methods, either you transform it into S domain and then proceed, or write the mesh equations in time domain and then convert it into S domain by taking Laplace transform and then find out. It is left to you. Okay. So now we'll do a problem and then we'll wind up. Okay. So, okay. 15 minutes is there. We can finish. Okay. So here values are given actually. Question is to find the transfer function V output of S by V input of S. So tell me how many meshes are here?
3.
3 meshes.
3
Okay.
meshes.
So first I'll mark the mesh currents. Okay. This one, it is left to you. Okay. Which you want to take as I1, I2 and I3. I'm taking this as I1. Second one mesh, this I'm taking. And the third one I'm taking as I3. Okay. Now let us proceed using the S domain format. Okay. If you want, you can do in the other way also. So I'm going to transform this particular circuit into S domain. So let us start. So what is V in of t will become what?
V in office.
Correct. V output of t will become
V output of S.
V.
Correct. Now 1 ohm will become what? 1 ohm
1 ohm
resistance.
itself.
1 ohm itself. So 1. Is it clear?
Yes, sir.
Okay. So 1 ohm. Now the inductor 2 Henry inductor will become what?
2 into S.
Correct. 2s. So it will become 2s. Now 1 Henry inductor will become
Yes,
S.
s. Correct. Now 1 farad capacitor will become what?
1 by S.
Correct.
By
1 by
S.
correct. Now 2 farad capacitor will become
1 by
1
2S.
by 2.
1 by
2S.
2s. Correct. 1 by 2s. Clear?
Yes, sir.
So
Yes.
you can see here I have marked. Now I1 of t will become
I1 of
I1 of
S.
S.
I1 of s. I2 of t will become I2 of s. And I3 of t will become I3 of s. Done? Any
Yes,
doubt?
sir.
Okay. Now let us write the mesh equation. So can someone tell me what is the first mesh equation?
Minus V in of S
Minus V in of s.
into 1 into I1 of S minus I3 of S.
Uh, Minus V in of s plus 1 into, correct?
Yes, sir.
Plus 1 into,
I1 of S minus I3 of S
correct.
plus 1 by S into I1 of S minus I2 of S.
Okay. Equal to
0.
okay. So what you told is correct. So I'm starting from here. First thing is minus V in of s plus 1 into I1 of s minus I3 of s plus 1 by s into I1 of s minus I2 of s equal to 0. Any doubt in this?
No, sir.
Okay. So now I am combining the terms of I1 of s, I2 of s, and I3s. So it will become I1 of s, correct. I1 of s, sorry, 1 plus 1 by s into I1 of s, correct. Terms of I1 of s, here you have 1, here you have 1 by s. So it will be equal to 1 plus 1 by s into I1 of s. I2s term is minus 1 by s. So minus 1 by s into I2 of s. I3 term is minus 1. So minus I3 of s equal to V in of s. Is it clear?
Yes, sir.
I'm taking the LCM also. So it will become s plus 1 by s into I1 of s minus 1 by s minus s by s equal to s by s. So after taking LCM, you will get like this. Is it clear?
Yes,
LCM
sir.
and then multiplying by s, you will get. I'm trying to simplify. If you want, you can write in this way itself. But if you are writing like this, it will become more easy. That's all. Okay. Now mesh 2. Can someone tell mesh 2 equation?
So minus 1 by S into I2 of S minus I1 of S.
Minus 1 by s will not come, right? So you are
1 by S.
starting
So it is
1
plus.
by s
Yes, sir.
into
Plus.
I2. Correct. 1 by s into I2 of s minus I1 of s. Next.
Plus S into I2 of S minus I3 of.
Next. Only that much.
Plus
Plus
1
1
by
by
2S
2S
into I2
into
of S.
I2 of S is equal
Correct.
to 0.
Correct. So I'm starting from here. So the first thing is 1 by s into, now we are considering mesh 2. So 1 by s into I2 minus I1 plus s into I2 minus I3 plus 1 by 2s into I2 of s equal to 0. Okay. Again, I'm combining the terms of I1, I2 and I3. So it will become minus 1 by s into I1 of s plus 1 by s plus 1 by 2s into I2 of s minus s into I3 of s equal to 0. I will take the LCM and cancel out everything. You will get like this. Is it okay?
Yes, sir.
Okay, so I got the mesh 2 equation also. Now I am going to write the mesh 3 equation. So can someone tell me what is mesh 3 equation?
2s into I3 of s
2s into I3 of s
plus s into I3 of s minus I2 of s
plus s into I3 of s minus I2 of s. Correct.
plus 1 into I3 of s minus I1 of s
Correct.
is
Plus
equal
1
to 0.
into I3 of s minus I1 of s equal to 0. Correct. So again, I'm telling if I'm starting from here, so 2s into I3 of s plus s into I3 minus I2 plus 1 into I3 minus I1 equal to 0. Again, I'm combining the terms, coefficients of I1, I2, I3. So it will be minus I1 of s minus s into I2 of s plus 2s plus s plus 1 into I3 of s. So this can be written like this. Is it clear? So we got the three mesh equations like this. These are the three mesh equations that we got. Now tell me in matrix form, what will be the size of the matrix?
3 cross 3.
3
Yeah,
cross
3
3.
cross 3. So can you tell me what will be the first row of the matrix? First row of the matrix.
S plus 1 minus s minus s. Sorry, minus 1 minus s.
First one will be s plus 1 minus 1 minus s. Okay. Second row,
Minus 2,
Minus
2s
minus.
plus 2s square plus 3 minus 2s square.
Okay. And the third row,
Minus
minus
1
1
minus s,
minus
okay,
3s
correct.
plus 1.
Okay, correct. Okay. So it will be like this, correct?
Yes, sir.
Okay. Now we will use Cramer's rule. So delta I'm finding. I hope you know how to find the determinant of a 3 cross 3 also, right?
Yes,
So it
sir.
will be this one, correct? S plus 1 into 2s square plus 3 into 3s plus 1 minus 2s cube. Then minus of minus 1 into minus 2 into 3s plus 1 minus 2s square minus s into this minus this. So it will be like this. I hope you guys know how to do this, correct? Okay, I have expanded and done everything. Okay, you can go through it. Okay, so finally I will get delta s 4s cube plus 4s raised to 4 plus 4s cube plus 7s square plus 3s plus 1. Clear?
Yes, sir.
Okay. Now tell me which delta I need to find, whether it is delta 1, delta 2, or delta 3.
Delta 3,
del
sir.
Delta,
3.
which current we have to find? Where is the output?
delta
Output
2
delta 2, because output is equal to what? What is the expression for output voltage? V output of S. V
1
output
by
of S.
2s into I2 of s.
Correct. 1 by 2s into I2 of S, which means that I need to find out what is I2 of S. Correct. I2 of S, if you want to find out, what we have to find out? Delta 2. Okay. Suppose the output is across this inductor, then what you will find?
delta 3
Correct. Now tell me, suppose the output I am taking across this capacitor, what will you find? What all things you have to find?
Delta 2 and delta 1.
Correct. Delta 2 and delta 1 you have to find. Then only you will get I1 and I2. Then only you will get the output voltage. Understood. So based on where is the output taken from, you have to find out delta 1, delta 2, or delta 3. Is it clear?
Yes, sir.
So for
yes
this
sir.
particular case, you have to find out I2, which means that delta 2 I am going to find. So to find delta 2, what will I do? I will replace the second column with the output matrix. Clear. And then find the determinant. Okay, so this is the determinant. I am simplifying it. Okay, so this is the determinant. So once I know delta 2, I can find out what is I2. I2 of s is delta 2 by delta, and substituting the values, you will get like this. Now, what is V output of S? You guys just now told. What is V output of S?
1 by 2s into I2 of s.
Correct. 1 by 2s into I2 of S. So I'm going to substitute I2 of S in this particular equation. So you will get like this. So from this, I will get I2 V output of S by V input of S. Is it clear? S and S will get
Yes,
cancelled.
sir.
2 and 2 will get cancelled. You will get like this. Is it clear?
Yes, sir.
Okay. So I will yesterday's problems, were you able to do?
Yes, sir.
You got the answer, right?
Yes, sir, we got.
Okay. So please do everything in that note itself, because 6th when you come, I want you guys to show me the work. Okay. And today also I will be giving some problems based on this modeling of electric systems. In the last slide, I will be mentioning before uploading, I will be mentioning the problems to be done and the final answer. So you yourself can verify. Okay. And next week, someday I will be conducting one. I want to give you one assignment based on this. So before that, I want to incorporate MATLAB and multisim together to check whether you got the correct answer. So one day next week, I will be asking you guys to to be ready with laptops so that we can do the simulation of one problem. And after that, I will be floating one assignment. Based on that, you have to write the assignment and do the simulation. And when you come back on 6th, you have to submit the same. Is it clear?
Yes, sir.
Yes, sir.
Okay. Any doubts?